Okay, today we are going to start lesson two. Lesson two. Lesson two is about how to determine type of roots of the quadratic equation. Quadratic equation. Okay, so in the beginning, there is a general form for the quadratic equation. It's ax squared plus bx plus c equal 0. So this is the general form of the quadratic equation. To solve this equation, okay, by using the general formula, we can get the two roots, okay, by this rule. The general formula, x equal negative b plus or minus square root of b squared minus 4ac over 2a. So this is the form or the general formula to solve the equation by using the rule. Okay. So now, without solving the equation or without getting the two roots, we can know the type of these two roots. Okay, so how can we get the type of the roots without solving the equation? Simply, there's one solution for that. It's from the discriminant. Okay, so what's that discriminant? Actually, from the general formula, it's this part, b squared minus 4ac. This part is the discriminant. So, discriminant equal b squared minus 4ac. Okay, so now, after we write the equation, and then a and b and c, so direct substitution in the discriminant to get a numerical value, of course. So there are three cases for the discriminant. b squared minus 4ac. The first case, if the numerical value greater than 0, or in other words, positive value. So simply this means there are two different real roots. Okay, the second case, if the discriminant equals 0. So simply this means there are two equal real roots. The last case, of course, if the discriminant is smaller than 0, or in other words, negative value. So in this case, two complex and non-real. Complex and non-real. So this means there's imaginary part. Okay? So now, two complex and non-real roots. So first, again, to determine the types of the roots of the quadratic equation, we have to use this formula from the general formula, b squared minus 4ac, and this formula is the discriminant. Okay, so discriminant, if its numerical value greater than 0 or positive, this means two different real roots. If the discriminant is equal 0, so this means there are two equal real roots. And in the last case, if the discriminant is negative or less than 0, so the two roots are two complex and non-real roots. Okay? Any questions? Okay, so in the first case, if the discriminant is positive or greater than 0, so this means that there are two different real roots. So graphically, it will be like that. This is xy plane, and then the curve will be like this. Or otherwise, it will be like that. Okay, so this means that there are two intersection points with x-axis, and of course, real numbers, and also different. Because if this one is 3, this means maybe that one will be -1, for example. Or otherwise, if this one is 2, maybe this one is -1. Okay? So from the graph also, we can know the types of the roots. Okay, the second case, if the discriminant equals 0, we said that two equal real roots. Okay, like this. XY plane, and only one intersection point with x-axis, like that. Or like this. Or like this. Okay? So in this case, from the graph also, we have to know that the two roots are equal and real. Okay, because maybe the intersection at 2, at 3, at -4, whatever. Okay. Third case, complex roots and the non-real. So non-real means there is no intersection with x-axis. This means like that, xy plane, and there is no intersection with x-axis, like this or like this one. No problem. Oh no, there is intersection here. We have to draw it like this. Okay, so these three types of the roots. The first one, discriminant positive, two different real roots, 0, 2 equal real roots, negative or smaller than 0, 2 complex and non-real roots. Okay, let's solve some examples related to this point. The first example, determine the type of the two roots of the following equation: x squared minus 3x plus 5 equals 0. So simply a equal 1, b equal -3, c equal 5. Discriminant will equal b squared minus 4ac. So b squared 9 minus 4ac minus 4 times a times c. 4 times 1 times 5. So this means 9 minus 20. So it will equal -11. Okay, negative quantity. So, of course, 2 complex and non-real roots. I'm done. Okay, guys, any question? Okay.
No.
Okay, great. Another example. X squared plus 10x plus 25 equals 0. Okay, solution. A equal 1, B equal 10, C equal 25. Discriminant equal B squared minus 4AC. So B squared 100 minus 4AC. So 100 minus 100. So simply 0. Okay, discriminant equals 0. 2 equal
Two equal roots.
real roots. Very good. Exactly. Okay. One more question like that. 3x squared plus 10x minus 4 equals 0. So now a equals 3, B equal 10, C equal -4. Discriminant. B squared minus 4AC equal B squared 100 minus 4 times A 3 times C -4. Okay, so it will equal 100 minus 4 times 3, it's 12. 12 times 4, 48. Negative, positive. 48, so equal 148. Positive value, yes. So in this case, two different real roots. That's it. Okay, guys, is it clear?
Yes.
Okay, great. Okay, next example. In the following example, prove that the units of the equation 7x squared minus 11x plus 5 equals 0, 2 complex, non-real, and find the roots. Okay, it's the same exactly like before. We will check the types of the roots to prove that they are complex, and then we will get the two roots. Okay, so the first step, A equal 7, B equal -11, C equal 5, discriminant B squared minus 4AC equal, now B squared 121, -11 squared 121 times, minus 4AC, 4 times 7 times C 5. So 121 minus 4 times 7, it's 28 times 5, 140. So this means it will equal -19. Okay, it's a negative less than 0 or negative. Then the two roots are the required complex and non-real. So that was the first part of the question, correct?
Correct.
Now the second part of the question, then find the two roots. It's very easy because I think there is part of the question already we solved it. I'm going to clear the question itself and write down the remaining part of the answer up there. Okay, find the roots. General formula, x equal -b, positive or negative, square root of b squared minus 4ac minus 4ac over 2a. Okay, it will equal -b means 11 plus or minus the square root of -19, correct? No need to write it one more time. We already got it. So -90 over 2a, 14. So now 11 plus or minus, okay? Square root of 19, I plus first, or minus over 14. So the two roots, I'm going to write it here. 11 plus square root of 19, I over 14, and 11 minus the square root of 19, I over 14. That's it. Okay, guys, any questions?
No.
This one is also clear?
Yeah. Yes.
Okay, great. Now the next example. The next example, if the two roots of the equation x squared minus kx plus 2k minus 4x plus 5 equals 0. The two roots are equal. Find k. Find k and the two roots. Okay. Before solving this question, we have to write it in the form of ax squared plus bx plus c equals 0, correct? So now, concentrate well in this point. x squared, kx, 4x. So this means the coefficient of x is not only negative k or negative 4. So now, there will be a common factor, okay? For x, so this means minus k plus 4x. Okay? Clear, guys?
Clear.
So we have to group all the terms of x. I mean to negative kx and the negative 4x, so that b, or the coefficient of x, will be this one. It's not only negative k or only negative 4. No, it will be negative than k plus 4. Okay? Again. If the question is like this, x squared plus 2x plus kx plus 7 equals 0. Now, if I want to ask you about a, you will tell me it will equal 1 because it's the coefficient of x squared, correct? But what about b? What do you suppose to say? Is it 2 or k? Because both of them are x. So coefficient is what? It's not 2 only and also not k only. Then now x is a common factor, and between two brackets 2 plus k, correct? Okay. We did the same on the question. Here negative k, negative 4. So x is a common factor, and the remaining two coefficients will be k plus 4, and the negative will be outside the brackets. Correct? Okay, so what will be the remaining terms? These two terms, 2k plus 5. So plus 2k plus 5, like this, plus 2k plus 5 equals 0. Now, a equal 1, b equal, b equal what? Negative k plus 4. Very good. And what about c? Is it 2k only, or 2k plus 5, or only 5? Of course, 2k plus 5.
2k plus 5.
Exactly. 2k plus 5. Okay. So now I'm going to get the discriminant. It's a given in the question that the two roots are equal. So this means I will get the value of the discriminant and make it equal to 0, right? Because the two roots are equal, so this means the discriminant equals 0. So now, b squared minus 4ac equal b squared. This means we are going to terminate this negative sign, of course. So k plus 4 to the power 2. Minus 4ac minus 4a equal 1, c times 2k plus 5. Okay, now k plus 4 to the power of 2. K squared, the first square, the plus first times the second times 2, 8k. Second squared, 16, minus, multiply this 4 by the bracket, 4 times 2k, 8k, minus 4 times 5, 20. Okay, will equal k squared positive 8k, negative 8k, 0. So the remaining two terms, 16 and a negative 20. So k squared minus 4 only. And because the two roots are equal, so discriminant will equal 0. So k squared equal 4. So this means k equal positive or negative 2. Correct, guys?
Correct.
Are we clear till this point?
Yes.
Okay. So now I got the value of k. It will equal positive or negative 2. So the next step is to get the two roots. Okay. Do I suppose to use k as equal positive 2 or negative 2? No. No priority. Okay. So we are going to solve the question within the two solutions. First time if k equal 2, second time if k equal negative 2. Okay, so go ahead and solve the question. I'm going to clear this one, all the question, no need for this. Now, we said that k equal positive or negative 2 at k equal 2. Okay, just 1 second, guys. Okay, let's continue. So we said that we will use k equal to or substitute in the equation by the value of k equal to and get the results, and then also again by k equal negative 2. Okay, the first step at k equal to, so the equation it's here. So it will becomes x squared minus k plus 4. It's 2 plus 4. Now k equal 2. So 2 plus 4 means 6x. Plus 2k means 2 times 2. 4 plus 5, 9 equal 0. Okay. So we want to get the two roots. So simply, I think this one is factorizable, right? So it will become like that. X minus 3, done, right? So x equal 3. So the roots are 3. Okay. So at k equal 2, the two roots are equal and each one of them equal 3. Two roots equal 3. Okay. So that was the first step. At k equal 2. Now, at k equal negative 2, at k equal negative 2, so the equation will be x squared. Now here, this one is negative 2. Negative 2 plus 4, 2. So minus 2x. 2 times negative 2. Negative 4 plus 5 means plus 1 equals 0. Can we factorize it? Yes, of course. It will be like this. X and X. Two numbers, their product is 1 and their sum is 2. 1 and 1. Negative, negative equals 0. X equal 1. 2 roots equal 1. Finished.
Mister, what if you got two different roots for x?
That's
This means you got the
impossible.
value of k wrong?
It's impossible. Why it's impossible? Because it's given in the question that the two roots are equal. So if you will get two different roots, so this means, of course, there is a mistake in your answer. Okay?
Okay.
Okay. That sounds very good. Okay. Let's continue another example. And the next example, find the real value of m. Find value of m. Okay. What should satisfy the equation? X squared minus 2m minus 1 x plus m squared equals 0. Okay. Has no real roots. Okay. What do we mean by has no real roots. So this simply means the roots are complex. So this means the discriminant is negative, right? So simply, it's a given in the question that this equation has no real roots. So discriminant b squared minus 4ac smaller than 0. Okay. B squared, where is B? Of course, it's the coefficient of X. It's this one. So it's already to the power 2, so we can terminate the negative sign. So 2m minus 1 all to the power 2 minus 4a 1 c m squared. This one less than 0. Okay. Now the first bracket to the power 2, first term squared, 4m squared minus first times the second times 2, 4m plus second squared 1 minus 4m squared less than 0. Okay. Now guys, 4m squared minus 4m squared, so 0. Now the remaining terms, negative 4m plus 1 smaller than 0. It's an equality, so it's very easy to solve it. Now,
Mister, what about the negative?
variable inside and the numbers and different side, like equation. So negative 4m smaller than, shift this one here, negative 1. So now I'm going to divide that inequality by negative 4. Take care. If you will divide or multiply the inequality by a negative number, you have to change the symbol. So now I'm going to divide by negative 4. So concentrate well. Change the symbol. Why? Because I divide the inequality by a negative number or multiply the inequality by a negative number. So simply m greater than quarter. Correct? Then what will be the value of m? I'm going to clear this part. No need for this now. Now we got that m greater than quarter. So m belongs to the interval. It's a greater than quarter. So quarter and positive infinity. Of course, a positive infinity is opened from that side. Here, is it greater than only or greater than or equal? No, it's a greater than, so also open. I'm done. So this will be all possible values for m, so that the two roots are not real. Is it clear, guys?
Mister, but there was a negative.
Hmm?
There was a negative. It was like x
Which
squared
negative?
minus
Which
2m
negative?
minus 1.
Hmm?
It was x squared minus 2m minus 1.
It was what again?
X squared minus between the squares
Okay,
2m
so
minus 1.
okay, no problem. It's a b squared. That negative will be positive, of course. So that's why I terminated that negative directly. Correct?
Okay.
Now it becomes clear.
Okay.
I mean to that if there is a number like this, 7 plus 1 between two brackets, and there is negative, and then I want to get this value all to the power 2. Of course, this negative will be positive, correct? 7 plus 1, it's 8. 8 squared, or even negative 8 squared, it's a 64. That's why I terminated that negative from the beginning. Correct, guys? Okay, another question. So the same idea exactly. Find the value of k. Find values of k, which satisfy the equation x squared plus 2 times k minus 1, x plus k squared equal 0 has two real roots. Okay, now my question, it's mentioned in the question that the equation has two real roots. So now, do I supposed to say that they are two equal roots or they are two different roots? I don't know. Maybe both, right? So first, discriminant. B squared minus 4ac. Two real roots. I don't know if they are equal or not. If they are not equal, greater than. If they are equal or equal 0. Correct, guys? So in this case, not only greater than or not only equal. Both cases. Because it's not mentioned accurately if they are equal or different. It's just mentioned in the question. Two real roots. That's why I wrote greater than or equal 0. Okay, continue. B squared, where is B? This one. So now, 2 times k minus 1. So, 2 squared, 4. This bracket squared, the bracket to the power 2. Minus 4ac, 4 times a1 c k squared, greater than or equal 0. Okay, are we clear till this point?
Yes.
Okay, now simplify the question step by step. This bracket squared, it will equal, this is 4 first, then the bracket k minus 1 all to the power 2, the first term squared, k squared, minus first times the second times 2, 2k, plus second squared plus 1. Then minus 4 times 1 times k squared means of minus 4k squared, greater than 0 or equal. Okay. Now, multiply 4 by the bracket, 4k squared minus 8k plus 4 minus 4k squared greater than or equal 0. Okay, negative 4k squared, positive 4k squared. Now, negative 8k plus 4 greater than or equal 0. Okay, I'm going to shift that number to the other side. But first, let me clear some area from the board. Like this is enough. Okay. So now, negative 8k, shift this number, greater than or equal negative 4. Now, I'm going to divide the inequality by the coefficient of k, which is equal negative 8 divided by negative 8. Take care. I'm dividing by negative, so k smaller than, change it to simple, or equal negative 4 over negative 8. So k smaller than or equal half. Okay, guys?
Yes, okay.
Okay, great. Now, the last step of a solution, k belongs to the interval smaller than half. So negative infinity and half. Negative infinity, of course, opened. Half, smaller than or equal, closed from the side of half. That's it. The question finished. Okay, guys? Is it clear or not? All of you, please, guys, just acknowledge that this question is clear.
It's clear.
Clear.
Yes, clear.
Okay. Do we have any questions? Okay.
No.
Okay, great. So let's solve another one. The next question is as follows. Prove that for all values of A, there is no real roots for this equation. 4x squared minus 12ax plus 9a squared plus 4 equals 0. Okay. So simply, what's the difference between this question and any other question? Nothing, of course. Here we want to prove that this equation has no real roots. That's it. So write down the discriminant, substitute, get the value of the discriminant. Of course, it has to be negative. So there is no real roots for this equation. That's it. Okay. Now, A, what do you think about A? It's 4x squared. So A equal
4.
4. Okay. B, 12a, right? C, 9a squared plus 4. So now, discriminant equal b squared minus 4ac, 12 equal b squared negative 12a all to the power 2 minus 4 times a 4 times c 9 9a squared plus 4. Correct, guys?
Correct.
Okay. The first term to the power 2, 12 squared, 144, a squared, minus 4 times 4, it's a 16. 16 times, this one is 16, times 9, a squared. 16 times 9, it will equal 144, a squared, minus, because we will multiply it by the second term also, 16 times 4, 64. Okay, so simply, this term and this term and its additive inverse. So this one and this one are 0, so it will equal negative 64. Less than 0, yes. So no real roots. That's it. Because the discriminant is negative. Correct, guys?
Yes, correct.
Any questions?
No.
Okay, the next point, we said that the equation of the quadratic function or the quadratic equation, its form is ax squared plus bx plus c equal 0. Okay, now, F. The coefficients a and b and c are rational numbers and discriminant is perfect square. Perfect square, guys, means a number which we can write it in the form of a number to the power 2 or the number which has a square root, in other words. Okay, so if a and b and c, the coefficients are rational numbers and the discriminant is perfect square, so what will be my deduction or conclusion? Roots are real rational numbers. Okay, so this is the first case. 3 coefficients are rational, discriminant perfect square, then the roots are real rational numbers. Okay, the second case, if one of the 3 coefficients or 2 or even the 3 coefficients are irrational numbers, Okay, can we take one example? Of course. If the equation is like this, x squared minus 2 square root of 5 plus 1 equal 6. 2 square root of 5x plus 1 equals 0. So here A rational, A and C also, but B irrational. Okay? So, and also F, discriminant is perfect square, the deduction, therefore, roots are real, but irrational numbers. Okay? Now this point is clear, guys?
Yes.
Okay, great. So let's solve the examples, okay, related to this point. Actually, there's one example I want to solve it so that we can understand this point well. And this question, if A and B are rational numbers, or in other words, belongs to Q, because we denote the rational number or the set of rational numbers by Q. Okay, so if this A and B belongs to Q or rational numbers, prove the two roots of ax squared plus a squared plus b squared x plus ab squared equals 0 are rational. Okay, how to solve this question? It's very easy. First point, it's a given that a and b are rational numbers. So this means the three coefficients are rational. This one is rational, this one, this one. Correct, guys? So the three coefficients are rational numbers. So that was the first condition. Okay. So we have to check the discriminant. Is it perfect square or not? So discriminant b squared minus 4ac equal b squared, this term, a power 2 plus b power 2 all to the power 2. A squared plus b squared all to the power 2 minus 4 times a, it was a times c, ab squared, ab squared. Okay, so this one to the power 2, of course, first squared, a to the power 4, plus first times the second times 2, 2a squared, b squared, plus second squared, b to the power 4, minus, now multiply 4 by ab squared, 4a power 2, b power 2. Okay?
Okay.
Okay, that's great actually. So now simplify the terms. A to the power 4, 2a squared b squared, 4a squared b squared, like terms, 2 minus 4, so it will becomes negative 2a squared b squared, then plus this term b to the power 4. From the first moment, okay, it seems to be a perfect square, right? Why? Because if I'm going to factorize this, a squared, b to the power 2, b to the power 2 minus minus. Two brackets with the same variables and the same signs. So it's a squared minus b squared all to the power 2. Perfect square? Yes. So coefficients are rational numbers. Discriminant is a perfect square. Then the two roots are rational numbers. That required in the question. Okay, guys? So now, the remaining step is to write down. 1 second. Since A and B are rational and the discriminant is perfect square, therefore roots are rational. That's it. Is it clear, guys? Any questions?
Mister, how did we know that A and B are rational?
It's a given in the question if A and B are rational numbers, right?
Okay, so what about C?
What is that C? It's AB squared. Rational number times a rational number. So rational number, of course, right? Because rational number or any set of numbers is closed set, correct?
No, I don't understand.
Again, I'm going to explain it. This one is a rational number and B is a rational number. It's given, correct? If you will add two rational numbers or multiply two rational numbers, what will be the result? A rational number or a different number?
Okay.
That's it.
It will
I
be
mean,
rational.
like half is rational, two is rational. If you will get the sum of two rational numbers, of course it will be a rational number. If you will get the product, half times a quarter, 1/8, two rational numbers, their product also is a rational number. Because this set of numbers is closed, right? The closure property, correct? We studied that from grade 4 till second preparatory, right?
Right.
Okay, great. Now this point is clear to all of you guys?
Yes.
Okay. Okay, the next part in the lesson, or to be more accurate, the last part. We said that the quadratic equation is ax squared plus bx plus c equals 0. If a and b and c are real numbers and discriminant negative, or in other words, less than 0. Therefore, two roots are complex. Of course, we know that if the two roots, if the discriminant is negative, so this means the two roots are complex and not real roots. But if the coefficient also are real numbers, so this means the two roots are conjugate complex numbers. Conjugate means what? Means like 1 plus I, and the other one will be 1 minus I, or 3 plus 2I, and the other one will be 3 minus 2I. As we explained before, the conjugate of the complex number, we will only change the sign of the imaginary part. Let's check that using one example. If there is equation like this, x squared minus 2x plus 2 equals 0. Before solving this one and to make sure from our conclusion, here a equal 1, b equal -2, c equal 2. The three coefficients are real numbers. Okay. And discriminant equal b squared minus 4ac equal b squared 4 minus 4ac 8. So the discriminant equal -4. It's smaller than 0 or negative. Therefore, roots are conjugate complex roots. Okay. I'm going to verify that result using the general formula. X equal -b plus or minus square root of b squared minus 4ac over 2a, so it will equal negative b, b equal negative 2, so 2 plus or minus square root. Discriminant, we got its value, negative 4 over 2a means 2, so it will equal 2 plus or minus 2i over 2. Now 2 from the numerator as a common factor, so 1 plus or minus I over 2. Now simplify by termination 2 and 2, so it will equal 1 plus or minus I. So the two roots, 1 plus I and 1 minus I. Exactly, that's correct. Conjugate complex, 1 plus I and 1 minus I. Okay, guys, are we clear? Any questions? Any questions?
No. No, thank you.
Okay, great. So actually, that was lesson 2. Hopefully all of you understand these points. Thank you guys for your time.